Hey guys, welcome to day 5 of 811. 811 is kind of a big section. It's taken us a while to get through. It's just because there's a lot of stuff to talk about in this particular section. But we really only have a couple of things left to take care of in this section, and that's going to be vocabulary and some notation stuff that we need to talk about. All right, so we'll kind of take care of the vocabulary stuff first, and then we'll switch over to MyOpenMath and actually look at some of the MyOpenMath problems that are posted for day 5, and that's where we'll talk about some of the notation stuff concerning end behavior that we need to talk about. All right, so let's go and get started here. We're going to talk about things called roots, zeros, x-intercepts, and factors, and all of these things are related in a sense. So we're going to talk about how they're related and what's different about them, because you're going to see these words throughout this unit. You're going to see the word roots, you're going to see the word zeros, x-intercepts, and factors, and you really need to know the difference, especially when you start doing the problems on MyOpenMath, because how these things are written differ. And so it might be a little frustrating on MyOpenMath if they ask for factors, but you write a root instead, and you get those mixed up, right? So let's take a look at a polynomial. We have a polynomial here, x minus 2 times x plus 1 squared. And the first thing we want to talk about is what are the roots, okay? So the roots are the numbers, essentially, that make each of these linear factors be zeros. So when I look at this x minus 2, the value of x that makes this entire parenthesis be a 0 is 2, because 2 minus 2 is 0. So one of our roots is going to be a 2. So I'm going to list that. You just write the number 2. That's it. Okay. Then we come over to this other linear factor. We have an x plus 1, and the value of x that makes that be a 0 is negative 1. Negative 1 plus 1 is 0. So I'm going to list that, negative 1. Now you notice how this particular factor has an exponent of 2, so that means that this factor happens twice. So technically, we actually have 2 roots of negative 1. So 2, negative 1, and negative 1. Even though they're the same root, it's that negative 1 happens twice because there are actually 2 factors of this. Okay? Now this other word, zeros, zeros are the exact same thing as the roots. It's just another word that means the same thing. They call them zeros in some textbooks because they are the values of x that make the zeros inside of the parentheses. Okay? So I'm going to go ahead and list those again. We just list those as numbers. So 2, negative 1, and negative 1 would be the zeros. All right? X-intercepts, right? X-intercepts are different. X-intercepts are points, right? So when we list x-intercepts, we need to list them as points, like ordered pairs, all right? So we talked about in the previous section of notes that the x-intercepts can be found by looking at these factors. So we have an x minus 2, which means we're going to have an x-intercept at 2 comma 0, okay? So there's a little bit of a sign switch, right? So we had a minus 2, which created an x-intercept at positive 2, right? So we can actually just take a root and turn it into an x-intercept by writing it as a point. So then I can say, okay, well, we've got a negative 1, so I'm going to say negative 1 comma 0. And if you look at the graph of this thing, there's only one x-intercept at negative 1, 0. So we don't need to list it twice, right? Then the last box over here, factors. Factors are these entire parentheses themselves. So we do have a factor of x minus 2, and we have another factor of x plus 1, but there is 2 of those factors, so we would say x plus 1 twice, right? So what if we are in standard form, right? What do we do if we're in standard form? Well, what I would do to find out what the roots, zeros, and x-intercepts are, these things are much easier to see if you are in factored form, but we're not. So what we're going to do is we're going to work backwards. I'm going to start with the graph, and I'm going to find the x-intercepts by looking at the graph. And so I'm going to pull up my calculator here, and we'll take a look at this thing and see what we got. So I'm going to enter this in. We've got x to the 4th plus 2x to the 3rd minus 13x squared minus 14x. Kind of regretting picking this long polynomial now. That's all right. Plus 24 on the end, and let's do a zoom 6 for a standardized screen and see what we get. Kind of bring this up. Big one here. Okay. So here we go. We can see our polynomial, and really all we're interested in here are the x-intercepts. It looks like at 1, 2, 3, 4. So -4, -2, and then another one at 1, and another one at +2. So let's go over here. Let's write down these x-intercepts that we got. So I'm going to say, okay, well, we got an x-intercept at -4, 0. We have another one at -2, 0. We had another one at 1, 0. And then we had another x-intercept at 3, 0. So now we have our x-intercepts, right? So we have this piece of the puzzle. And remember how the roots and the x-intercepts were related up here. The root was inside of the x-intercept, just not written as a point. So I can actually take the x values inside of these intercepts and just write them over here as roots, right? So we've got -4, -2, 1, and 3, and the zeros would be exactly the same. And then to write my factors, I can just say, well, a factor always looks like this. It's always going to be x, right? And then there's going to be something here, and it's going to be the opposite of what I see here. So if this was a -4, that means I had a factor of x plus 4. I'll have another factor of x plus 2. All right, so this one is a +1, so that means I'm going to have a factor of x minus 1, and this one was a +3, so I'll have a factor of x minus 3. And then I can actually write the factored form, so I can say f of x equals, and I could say, okay, well, I've got x plus 4 times x minus 1 times x plus 2 times x minus 3. And then to get my leading coefficient out front, I just look at the leading coefficient in standard form. It was a 1, so the leading coefficient in standard form will also be a 1. So these are actually the same polynomial. One is in standard form. One is in standard form, one is in factored form here. All right, so that's working that process backwards. So really what we just figured out is a method for factoring a 4th degree polynomial, and we didn't need a box and diamond or anything like that. We just used the graph to figure out how to do that.